Important because we put supply, that is our cost of producing the product, together with demand, the price that we can charge and the amount of the product that someone will buy, that determines the profit for the business. As we see in this diagram, that profit is driven by what we call average total cost, or ATC, compared to the price that we're charging, and then all multiplied by the number of units sold. So our price that we're charging, P, minus our average total cost, ATC, times Q, the quantity, tells us how much money is the firm going to make. In other words, marketing research is key to understanding how the firm can maximize its profits over time by understanding what that demand curve looks like and what we can do to price our product appropriately. Now you should understand what role demand plays in your sales for your organization and see how different factors can impact your demand curve. To understand what demand for our product is, we need to first start by looking at some simple historical data related to price and our sales. I'm in the 0102 begin Excel file. Now we've got here to start out with is just a very simple example of price and sales data for two particular products. And this is just going to illustrate for us the concept of demand and how we might apply it in a business setting. So, beginning over here on the left, we have product number 1, and we've recorded data on our sales for that product at 3 different price levels. We tried a price of $75, $75.75, and then $76.50. And our demand over the same amount of time at each of these 3 different prices was 5,000 units, 4,900 units, and 4,760 units. That, of course, led to sales, which are simply equal to the price times the demand of $375,000, $371,175, and then $364,140. Now, I've also gone through and I've graphed all this down below, so we can see for product 1, what does our demand curve look like? Now, of course, we've got a very small range of prices here, so we don't have a lot of data, but this starts to give us a sense for what our demand curve might look like. Understanding the shape and type of demand curve we're facing is critical in market research. So let's go through and do this same exercise for product 2, shall we? So to determine our sales for each of these levels of price, I'm going to multiply our demand times our price. In this case, cell E2 times cell F2. So for product 2, at a price of 50, we sell 3,240 units. Then at a price of 60, we sell 2,250 units, resulting in sales of $135,000. And at a price of 70, we sell 1,650 units, resulting in sales of $115,500. Let's go through and graph this, shall we? So to do this, I'm going to highlight my price and demand for product number 2, and then I'm going to go through and I'm going to insert a scatter plot chart. Now, there's a variety of scatter plot charts you can choose from. I like the one that has the connected lines and points. So I'm going to add this. I'm going to shrink it down to fit a little bit better. And what we see here is that Excel has started out by putting our price on the horizontal x-axis and our demand on the y-axis. Now, that's just not traditionally how demand curves look when we kind of present them. So just in order to be consistent with sort of the traditional style for presenting demand curves, I'm going to go ahead and flip these axes around. And I'll do that by clicking on the area where the data is and then clicking Select Data. Now I'm going to go through and I'm going to edit my data for demand 2. And I'm going to change my x values to, instead of being column E, be column F. And I'm going to change my y values to be column E. So now X is F2 to F4, and Y is E2 to E4. And when I do that, voila, now my demand curve looks like it should. And I'll go ahead and I'll change this to product 2. Now you're all set to be able to go through and come up with a basic demand curve for a product of your own. Try doing this with 1 or 2 of the products your firm sells. When it comes to doing market research in the real world, anyone dealing with this area needs to be able to take data generated by the business and then clean up that data for use in market research analysis, including things like understanding and estimating the demand curve. Let's look at how that process works. I'm in the 0103 begin Excel file. Now what we see here is data from a firm related to all the sales they've made over time. This particular company, a fictional firm that we call RedTech30, provides a variety of different high-tech products, including drone blueprints. Now what we see is the firm has 2 major products that we're looking at in this particular case. Product 102 and product 101, which are blueprints for 2 different drones, the B² blueprint and the All Eyes drone blueprint. And we see, as you'd expect from most sales reports, the level of sales on any particular day for a particular product. So on 9/1/2017, as an example, the firm sold 10 copies of the B² robot blueprint at $8.99. On 9/6/2017, the firm sells 21 copies of the All Eyes drone blueprint at $4.99. What's important here, from an understanding demand perspective, is that the firm varies the price that it charges over time. If you only ever charge one price for a product, if you never experiment and move that price up or down or offer sales or discounts to your customer, then there's nothing to estimate with demand. We only know what we could sell at that particular price. Which of course begs the question, are we charging the right price? Out of all the possible prices we could have charged, was $4.99 exactly the right price to charge for this particular drone blueprint? Probably not, right? As in so much of marketing, there's testing and iteration that is required when it comes to understanding what the right price is. Now, over time, if we scroll down, we see the firm has charged different prices. In order to go through and organize this data a little bit better, though, we need to isolate the particular product in question and then the prices that have been charged over time. So I'm going to go ahead and I'm going to sort all of my data by hitting Control-A to select everything, and then coming over to the Data tab and clicking Sort. And rather than sorting by order date, I'm going to add another level, and I'll sort first by the product number and then by order date. And this way, we'll go through and separate. And now we see all of the product 101s and the dates those orders were placed. Then if we scroll down, we see all of the product 102s and the dates those orders were placed. So this is a good start. We've gone from simply having a mass of different products all lumped together, even though they're not related to one another, to having just individual products grouped together. Next, we need a way to go through and understand what our total sales are for any given period of time, say for a 1-month period. So I'm going to use this last column, L, and I'm going to create a month indicator variable by using the month formula. So I type equals month, open parentheses, and then I'm going to go through and pick the order date in question that I'm interested in. So in this case, my month is going to be based on the order date that a particular order occurs on. When I'm done, I click enter. And if I do this all the way down the entire column, this will let me go through and ensure that I've got the correct month for every single order. So now we see all of the orders that occurred in month 12, in month 11, month 10, etc. This is nice not only for kind of grouping orders together, but also for understanding seasonality, which is a key element in understanding demand. Most businesses face some level of seasonality. For instance, you might see orders pick up in the fourth quarter as we get close to Christmas. Either way, we've now gone through and done some basic organization on our data. We've put our particular types of products together, and we've grouped them based on the month in which those orders occurred. Now you should have a better understanding of what it takes to go through and start building a holistic data set that'll help us to estimate demand and the appropriate price for a product. Try putting one together based on your own data, just as I've shown you here. A cornerstone of market research is establishing estimates for demand and for sales for a particular product. One basic tool that we can use to start down that path is a moving average, but the moving average is built around seasonality. I'm in the 0104 Begin Excel sheet. Now what we have here is a sheet that's going to help us to establish the seasonality for a particular product. So there's two tabs that we're interested in. 0104, seasonality, is our first tab, the one we started on. And this is going to show us the number of units that we sell for a particular product in a particular month. And then our 0103, all sales sheet, which in essence looks just like the kind of information you get from any typical point of sale system or CRM that your company has, something like that. It essentially just shows us the customer name, customer type, product number, product names, etc., related to all the sales that occur over time for a particular firm. Now, what I want to do is go through and establish the amount or units sold of a particular product in a given month. So to do that, I'm going to use a SUMIF function. So the SUMIF function allows us to simply go through and evaluate a particular set of cells in Excel to see if they meet a given criteria. And if they do meet that criteria, then we add up all the numbers in those cells. So in this case, I'm going to look at my range of dates, months in this particular case, for a particular product, in this case, product BP101, and I'm going to see if they match with month number 1. If they do, then I'm going to sum up the number of units sold in that particular month. Now, what's important here is I'm only evaluating based on a single month number, month 1, and I only want this for a particular product, BP101. So if we look at our 0103 sheet, what I need to be sure that I'm doing is only evaluating across the cells for BP101. I don't want to be looking at the cells for BP102, this product number. So for that reason, I'm going from row 65 on the bottom all the way up to row number 2. Now, this is a common problem, of course, that you're going to face in the real world. We frequently mix together sales for different kinds of products, but the SUMIF function is going to handle it better if we kind of separated those out. So I've put in as my range L2 through L65, which correspond to the month, and then rows 2 through row 65 for BP101. Whenever that month is month 1, I'll add up column H, which is the number of units sold in that particular sale. When I do this, we have 128 units sold throughout this 2-year period in January for product BP101. Now, if I've anchored my cells properly by putting a $sign in front of my numbers, then I should be able to take this cell and just carry it down across the entire column. And we'll see now the total number of units sold for this particular product type over that 2-year period, but broken out by months. I can do the same thing for revenue. Now, however, I'm going to have to adjust my formula a little bit. Again, I'm looking for sales in January. Now, I want to make sure I'm still looking at that same month column, and so that's going to be column L. And this time, I'm going to need to look at my total sales in dollar terms. Let's see what column that is. Well, it looks like I want column K here, which has my order total in dollars. So I'm going to change this column from I to K. And doing this will then give me my revenue broken out by months for this particular product. And we can, of course, go through and check this by looking at the total amount of sales for this particular product versus the sales that we show. So summing this all up, it looks like our total sales here are $9,024.79. Let's see if that matches the sales for K2 through K65. Yep, $9,024.79. Looks like our formula worked. So great. Now we've broken out our sales based on units sold and dollar volume by months for a particular product. This allows us to examine and see if there's any seasonality. And sure enough, it looks like sales in the fourth quarter are on average heavier than throughout the rest of the year. September going into that fourth quarter, and then certainly October and December, sales generally are higher than in other parts of the year. This firm seems to have a little bit of seasonality for this particular product. At this point, you should be prepared to go through and analyze and look for seasonal patterns in data for your firm. Moving averages are a simple but effective basic tool we can use to start understanding the level of demand that a particular product faces. Let's take a look at how we can apply this in Excel. I'm in the 0105 Begin Excel file. Now, what we've done here is go through and take the forecasted level of demand for a hypothetical product for a particular firm, in this case, our hypothetical RedTech 30, based on actual demands from the last few months. So perhaps we're trying to forecast total dollar sales, for instance. Well, we've got dollar sales in October, November, and December of 45,000 down through 26,000. I want to make this a little bit easier to read, so let's just quickly change the format here. So I'm going to highlight those 3 cells by holding down the Shift key and then hitting the down arrow key 3 times. When I've done that, I'm now going to hold down Control and then the number 1 key, and that'll pull up my Format tab. And I'm going to change this over to be a number with a thousands comma separator. We now see what demand looks like over this past 3-month period. So we've used a basic moving average over the last 3 months to get our demand for January, and we're estimating that to be 34,097. Well, if we want to go through and build that going forward, we'd enter what the actual demand is in January, and then we can extend our forecast going forward. So if our demand in January is actually 35,000, well, once we have that figure, I can go through and forecast what my February sales will be based on what they actually were in January. And in this case, I'm forecasting 30,554. And again, we could do this for as many months as we'd like going forward. Maybe actual February sales are 40,000. Then my forecast for March is 33,817. And if March's actuals are 38,000, then my April forecast becomes 37,667. Pretty straightforward. An alternative approach to doing this, and one that's often a little bit more precise, is to use a weighted moving average, or WMA forecast. Now, that weighted moving average is going to assign weights to a particular month based on some sort of percentage or some sort of importance that we attribute to that particular month. So in this particular case, I've assigned month 1, that is October in our first example, to have a 20% weight, month 2 to have a 30% weight, and month 3 to have a 50% weight. And when I do that, my weighted moving average comes up with a forecast of 31,414. And again, I'll format this to make it a little bit easier to read by hitting Control and then the number 1 arrow key and changing that to 0 decimal places with that 1,000 separator. Now, the nice thing about using a weighted moving average is, with a simple moving average, we're assuming that all months have equal importance. The weighted moving average lets us say, well, maybe more recent months have more relevance for future performance if we're growing very quickly, or if there's issues of seasonality, we can take that into account using our weighted moving average. Whatever the approach is, whatever we think the appropriate percentages are, we can go through and apply that with the weighted moving average to better understand what our demand will actually be. This is really critical because as a market researcher, we need to be able to understand what we expect demand to be for a particular product before we even make any changes to our marketing, to our pricing, product attributes, etc. At this point, you should be able to go through and do a basic demand forecast using moving averages and weighted moving averages to potentially correct for seasonality issues. Again, this is a simple tool, but it does provide a great method for quick and dirty estimation of demand over time. One important role in market research is to help understand what the appropriate price for a particular product is and what the associated sales are when we change that price. We can use a tool called the price elasticity of demand, or simply elasticity, to help us understand how to set price. I'm in the 0106 begin Excel file. I'm using the 0106 elasticity sheet. This sheet helps us to go through and look at a series of prices that we've tried for a particular product over time. So this product, we've used a price of $4.99, $6.99, $9.99, $14.99, and $16.99 over time. And we're going to pull some data from our 0103 all sales sheet to help us to understand what the unit sales are at each of these different price points. To do this, I'm going to use my old friend, the SUMIF function. Now, the SUMIF function is going to sum up over a particular range. In this case, the product we're interested in, BP 101, is in the rows 2 through 65. We're going to look at price, which falls in column I, and compare that to the price that we've set here, $6.99. Whenever price in column I matches the $6.99 price here, we're going to go through and add up the unit sales from column H that occur there. So just to briefly look at this in our 0103 sheet, we see our price in column I, our quantity sold in column H, and that's what we're going to be capitalizing on to fill out our elasticity sheet. So doing this, I've anchored my cells using a dollar sign, and I'm simply going to drag and drop this down. And this shows us the number of units that we sell at each price point. We can apply the same thing to get our revenue. We're simply going to multiply the number of units sold times the price. And this shows us that, as we expect, because demand curves slope down, the higher that price is, the fewer the units that we sell. What's new here is we want to apply what's called a price elasticity. This price elasticity, in essence, just measures how sensitive customers are to an increase in price. In this particular case, we're going to be looking at the change in units sold for a price change from $4.99 to a price change to $6.99. Doing that, looking at our new sales, $341, minus our old sales of $399, divided by our old sales of $399, all divided by our change in price, that is $6.99 minus $4.99, divided by $4.99, we get an elasticity of 0.36. The smaller that number is in an absolute value term, that is, the closer it is to 0, the less sensitive customers are to price. A 0 value here would indicate that we didn't see any change in demand despite raising our price. That would be great. Of course, that rarely happens in the real world. I'm going to apply the same concept over time across each of our different price changes. And what we see here is that as we raise price more and more, looks like customers, the ones that we have remaining, get to be more and more sensitive to price. Going from $4.99 to $6.99 wasn't a big deal for our customers. But going from, say, $14.99 to $16.99, well, that is a big deal. We can use this concept of the elasticity to forecast what our sales will be for prices that we've never actually tried before. So maybe we're interested in a price of $7.99 for the product. We've never sold at $7.99. But we want to know what our sales would be. Well, in this case, I'm going to use my elasticity at the $6.99 and the $9.99 price. And I'm just taking a simple average between the two. And what happens when we do that? Well, going through and applying that elasticity and my unit sales at the $6.99 price, I project sales in this case of 313 units. That corresponds to revenue of $2,504.76. We could apply this to an $8.99 price as well. So I'll simply drag and drop that down because I've anchored my sales appropriately. And now what we see is at an $8.99 price, we project unit sales to fall from 313 to 242, and my revenue to come down to $174.93, largely based on a change in my elasticity for this particular price point. So what we see is, based on all this, we can go through and calibrate to determine what our optimal price should be. It looks like revenue is maximized at $2,504.76 with a price of $7.99. Doesn't necessarily mean that's the price we want to set. We don't know anything about costs yet, but it's a good place to start. Now you're ready to apply this concept of forecasts using price elasticity for your own unit sales. To get more accurate forecasts, oftentimes for new products, we need to look beyond simple moving averages, and we can't apply price elasticities either. So one tool to help us with this is the weighted moving average. Let me show you how this works with a new product category. I'm in the 0107 begin Excel file. Now we're looking at the 0107 new product sheet. Now, what we're going to do is look at a new product that we're going to call product number one. We're trying to come up with a forecast for product number one. And to do that, we're going to look at three existing products: existing product one, existing product two, and existing product three. For product number one, we think that it's got some features and similarities with all three of our existing products. So we've gone through and estimated that the level of demand for product number one is about 30% related to the level of demand for existing product one, about 50% related to the level of demand for existing product two, and 20% related to the level of demand for existing product three. Notice, these weights have to sum up to 1. So we're really trying to say here, on a percentage basis, how similar is our new product to each of those three existing products? Once we've decided that, we can go through and make a forecast using our weighted moving average technique. So to do that, in this case, I'm going to use my friend, the sum product function. And I'm simply going to multiply my array of different weights by the array of my existing unit sales. And when I do that, voila, I get my forecast. In January 2019, I'm forecasting 37,994. Now, going forward, if we have an estimate or a projection on what we think any of our other products will sell, we can estimate how much our new product would sell as a result. So maybe we're forecasting, for instance, 50,000, 60,000, and 70,000 in sales for each of our three existing products, product one, product two, and product three, in February. Well, to get a forecast for what it'll actually be going forward for product one, our new product, we'd simply take, again, our individual weights multiplied by our forecast for the existing products. Try filling out the rest of this on your own. We could go through and estimate what we think these remaining sales might be for our existing three products, and then come up with a corresponding forecast for the new product. At this point, you should be able to make simple weighted moving average forecasts that better understand demand for new products like this one. One useful tool for forecasting in the market research field are regressions. But a regression by itself is of limited value. It tells us what factors affect sales, but not what our sales will be. But we can take the information from the regression and use it to create a demand forecast. Let me show you what I'm referring to. I'm in the 0108 begin Excel file. Now in this particular file, we've pulled information from our 0103 all sales sheet. So that first sheet shows us all of the sales for this firm over a period of time. I've pulled select pieces of data that let us run a regression. And what we're going to be interested in doing is understanding how price, month, and then the type of product impact the quantity sold. The regression is a good tool for us to start to do that. So I'm going to go to the Data tab, and this is where we would normally find a regression. But wait, what's going on? There's no Analysis Toolpack or data options here that I'm looking for. So what I conclude is that the appropriate add-in for Excel hasn't been installed. To deal with this, I'm going to click File, Options, Add-ins, and then Go next to Manage Excel Add-ins. Now I want to check the Analysis Toolpack, and I'll go ahead and add the Solver add-in as well. And when I do that, voila, I have new options. So what I'm looking for now is Data Analysis under the Analysis section in the Data tab. I'm going to click on that, and I'm going to scroll down. Now there's a variety of different analysis options here: moving averages, correlations, covariance, etc. I'm interested in regressions. So I'm going to click regression, and now I want to put in my Y range. Well, the Y range I'm looking for is going to be based on quantities. That's what I'm trying to understand. From here, I'm now going to choose my X's. So my X's in this case are going to be based on product number, price, and month. Certainly, we can go through and create dummy variables for customer state. I won't choose to do that, but if you'd like to do that on your own, it's a good exercise to go through. So I'm going to highlight the section from C through E for our relevant set of rows, 2 through 178. I'm going to add in labels, and I'll put in a confidence interval here of 90. By default, we're going to have a 95% confidence interval, but just for fun, I'll throw in that 90% as well. And we'll go ahead and put this all into our same existing worksheet just to be a little neater and cleaner. So I'm going to go ahead, and we'll put this in up at the top. So let's put it in, say, at cell H3. Now I'm going to click OK, and let's see what happens. Well, this spits out my regression. Now, what we'll observe here is, after we kind of neaten it up a little bit, I'm going to highlight the cells I'm interested in neatening up, hit Control and then the 1 key, and I'm going to change this to a 2 decimal number, and do the same thing down here below with my coefficients. Now, what we'll observe here, when we kind of take a look at it, is that this regression isn't great. We've only got an R-squared of 0.15. Again, that's largely because it's based on fabricated data, hypothetical data in this particular case, and also because we don't have a lot of variables that we're looking at. But in essence, what this is showing us is we can capture about 15% of the variation in units sold based simply on the product number, the price, and month. So product 1 tends to sell more than product 2, and the higher that price is, the fewer the units that we sell. As we go through the year, we sell more and more of the product. We tend to have seasonality, with the fourth quarter having more sales than later quarters. What's more important than anything else, though, is to look at our t-statistics and p-values. These t-statistics are greater than 2, or in this case, the absolute value of 2. What that tells us is product number and price are statistically significant drivers of our units sold. Said differently, price and the type of product we're selling are the big factors that we have to take into account when it comes to sales forecasting. Month is helpful, but it's really just a starting point. At this point, you should be prepared to go through and run a regression similar to this one on your own. Give it a try and see how you make out. Making full use of regressions in market research doesn't stop with just running the regression, we also need to be able to take that regression output and actually apply it to make a forecast. Let's take a look at how this is done. I'm in the 0109 begin Excel file. Now, if we look at our 0109 forecast sheet, we have a regression that was done in order to better understand the drivers of sales from a unit sales basis based on product number, price, and month. And our product number was just a one or two variable, so it was in essence a dummy variable. Moving from product 1 to product 2 sold an average of 14.17 fewer units. So if you're concerned about that factor, that's why we've done this way. Now, what I want to do is go through and construct a unit sales forecast. To do that, I'm going to take our coefficients of interest, the intercept, our product number, our price, and our month. Now, I'm going to apply to them, and I'll move this up just a little bit. So this is going to be our variable. Here's our coefficient, and we're going to apply the coefficients from our regression to this particular forecast. So this, in essence, that coefficient value represents the impact that a particular variable has on unit sales. What this intercept is saying is that all else equal, for no product number, for price 0, month, etc., we have an intercept of 67.78. In other words, we'd sell 68 units for just a generic product that was out there. Once we specify the product number and our price and our month, that helps us to come up with a full forecast value. So I'm going to put in my forecast values, and I'm always going to apply a value of 1 for my intercept. Then from here, I'm looking at my product number. Now, my two choices here are product 1 or product 2. Those are the two values that we're using. Let's just pretend we're looking at product 2 in this case. Now I want to look at what my price is. Let's say that my price is $9.99 as an example, and let's say that it's month 11. Well, in this particular case, how are we going to go through and come up with our output? Well, the output is simply going to be our forecasted values times the coefficient effect. So this shows us that for product number 2, we have a negative 28.35. And I'm going to change these to be a little more readable. Let's take away those decimal places. Having product number 2 versus product number 1 has a negative impact of 28 sales. Our current price is negative 34 sales. That's the impact. And then the month has an impact of positive 4 sales. So in order to come up with a forecasted value based on this particular set of expectations, we'd simply sum up all of the impacts of those individual coefficients. So this is our unit sales forecast. And I'll put a little box around it to kind of highlight this to make it easier to see. Now, the nice thing about doing a regression-based forecasting tool is we can go through and make changes to this to better understand what the impact would be. If we lower price to 34, what happens? Well, our unit sales forecast for a particular month now changes. If we're talking about product 1 instead, or we're talking about month 6 as an example, we can go through and alter these, and our unit sales forecast updates dynamically. Again, this is a very basic regression, and the R-squared value here indicates, because this is hypothetical data, that the regression is not going to be particularly accurate. But it does give us a good starting point to better understand what sales might be after taking into account a variety of different factors that will impact that individual product. Now you're ready to try applying this technique on your own. Give it a shot with a regression that you run. Try mixing up some of the different numbers. Perhaps as an example include other dummy variables or other variables from our original data and see if you can come up with a more accurate forecast figure.